Okay, let's dive in. You've brought us this really interesting article, Mindset Matters: Why Mathematicians Believe More in God Than Biologists or Physicists.
Yeah, by Jorge Garapires.
And honestly, the title alone is quite something, isn't it? It just jumps out because, well, it suggests something that really cuts against the usual way people talk about science and faith.
It absolutely does. The whole starting point for this deep dive, based on the article, is this pattern that keeps showing up in surveys of scientists.
Okay.
You see this really noticeable difference in how many believe in God, depending on their field. It's not just, a small thing. The article says it's significant.
Right, because usually the conversation is framed like science versus religion, or maybe science and religion fitting together somehow.
Yeah.
But it treats science like it's all one thing.
Exactly, but this source is saying, hang on a minute, it's actually way more complicated inside science itself.
So our mission here is to unpack what this author is arguing. Why this difference, especially between mathematicians and, say, biologists or physicists.
And what does that tell us, according to the author, about how the actual work you do, the mindset it creates, relates to belief? It goes beyond just faith versus evidence.
Okay, so let's get straight to it. The numbers. The article presents some pretty striking data, right?
Oh yeah, it jumps right in. It points to these surveys where, look, mathematicians, you're seeing maybe 30, even 40% expressing belief in God consistently.
Which was a pretty big chunk, especially when you think about scientists generally.
It really is. Now compare that, and the source makes this comparison very clear, with biologists and physicists.
And what are their numbers like?
Much lower, usually under 15%. And often it's actually down closer to like 5 or 10%.
Wow. Okay, that is a huge difference. You can see why the author thinks that needs explaining.
Definitely. It's not just some scientists believe, it's which ones, and the rates are so different. The source argues this isn't just chance.
It's not random.
No. The author thinks it's tied directly to how these different fields actually engage with reality, what kind of thinking that encourages day in, day out.
All right, so let's get into those arguments. Why the gap? What's the first big idea the author puts forward?
So the main explanation the source explores really contrasts the very nature of math versus fields like biology and physics. The author calls it clean abstractions versus messy realities.
Clean abstractions.
Hello?
Okay, that sounds like math.
That's exactly it. The source describes math as operating in this world of pure abstraction. It's all built on axioms, these basic truths you just accept, and then theorems you logically prove from them.
Right.
It's a world of perfect logical structures, things that mathematicians feel they discover rather than invent. It all fits together perfectly within its own rules.
So it's not about poking and trotting the physical world. It's more about exploring this internal world of logic.
Precisely. And the source suggests that for mathematicians, being immersed every day in this world of, elegance, order, and discoverable absolute truth, it can feel like you're seeing something deeper.
Like a glimpse behind the curtain?
Kind of. Almost like, the article says, a window to a grand design or a divine mind. The sheer beauty and orderliness they encounter could naturally resonate with the idea of some ultimate source of that order.
That actually makes a lot of sense. If your whole world is perfect systems and absolute proofs, it might feel like you're touching the blueprint of something ordered.
That's the author's point for the math side. Now, contrast that, and the article draws a really sharp contrast with biology and physics. These fields deal with the messy realities of the actual universe.
So the universe as it actually is, warts and all.
Exactly. These scientists are grappling with reality in its, raw state, which is often chaotic, seems indifferent, sometimes even brutal.
What examples does the source give for that messiness?
Well, it points to evolution in biology. It's presented not as some guided process aiming for perfection, but more like adaptation, driven by random genetic changes meeting whatever the environment throws at them.
So chance plays a huge role.
A massive role. There's no obvious, predetermined goal or design in the way we usually think of it. It's about survival, based on what works well enough right now, often due to luck or circumstance. Organisms aren't perfectly designed, they're just good enough.
Right, survival of the fittest or maybe luckiest, not necessarily the best designed.
Exactly. And the author argues that constantly working with processes driven by chance and necessity rather than conscious design fosters a different outlook.
Okay, and physics.
In physics, the source brings up quantum mechanics, which is famously weird, right? It often defies our basic, everyday logic.
Definitely. Things being in two places at once, uncertainty being fundamental.
Right. It deals with inherent uncertainty, probabilities, things like entanglement that just don't fit into a neat clockwork view of the universe.
Not like predictable billiard balls.
Not at all. And the source argues that biologists and physicists are wrestling daily with empirical data stuff they observe and measure from the real world, or they're building theories to explain phenomena that are incredibly complex, often unpredictable.
Things that resist easy answers.
Yeah, things that resist those neat, comforting stories about a clear plan or purpose. So this constant struggle with chaos, randomness, uncertainty, imperfections in the physical world, the article suggests it leaves less intuitive room in their professional thinking for traditional ideas of divine purpose or design shaping the universe they study.
So it's less about belief versus non-belief and more about how the texture of the reality they study influences their intuition about whether the universe feels ordered and designed or something else.
That's the core distinction the author is drawing here. The very nature of their subject matter shapes the mindset, and that in turn seems to affect the likelihood of believing in a god associated with order and design.
Okay, that's a really compelling point by itself. But the article doesn't stop there, does it? It brings in Francis Collins.
Ah, yes, Francis Collins. He's often the go-to example, isn't he? Brilliant scientist, leader of the Human Genome Project, and also openly religious.
Exactly. So how does the article handle him? Because he seems like a counterexample to this whole idea.
Well, the source uses Collins to introduce what it calls the Francis Collins paradox. It acknowledges his stature. Absolutely. Renowned geneticist, major scientific leader, person of faith, no question.
Okay, so what's the paradox?
The article immediately adds this crucial nuance. It points out that Collins' most famous roles, especially leading the Genome Project and later the NIH, were often more administrative and managerial.
Meaning not directly doing the lab work day to day.
Less about being a bench scientist deeply immersed in empirical data, as the source puts it. More about overseeing the whole massive operation.
So a distinction between leading the charge and being in the trenches running experiments or crunching theoretical numbers.
That's the core contrast. The article contrasts the mindset needed for leadership, strategic vision, managing huge, complex projects, diplomacy, thinking in terms of systems, imposing order with the mindset of the bench scientist dealing with messy experiments, or the theoretical physicist grappling with counterintuitive concepts.
I see where this is going. The leader is organizing complexity, while the researcher is confronting the inherent messiness or strangeness head-on.
Precisely. And here's the really provocative bit the author highlights. That administrative mindset, focused on bringing order, building systems, seeing the big picture goal. It might actually be, ironically, more compatible with a religious belief in design and purpose.
More compatible than the mindset of the person actually doing the frontline science.
That's the argument. More compatible than the mindset shaped by the chaotic grind of messy experimental data or the abstract weirdness of fundamental physics.
That is ironic. You might think the person looking deepest into nature's secrets would be the one whose views on a designer are most directly shaped by the science. But this suggests the person managing the process finds it more aligned with purpose.
It's a subtle but important distinction the author makes. The skills for high-level administration, organizing, planning, structuring, systems thinking might resonate more easily with the idea of an organized, planned, purposeful universe.
Whereas the bench scientist dealing with failed experiments, contamination, weird results,
or the theorist facing quantum uncertainty, their daily professional reality might make a neat, perfect, divine plan feel less, intuitive, less aligned with what they actually experience in their work.
And the article's conclusion on Collins is pretty direct then.
Yes, the source wraps up the point on Collins by saying, look, it's fine to admire him, his achievements, his personal synthesis of faith and science, that's fair. But the mindset required for his high-level administrative role should not be confused with the mindset required to do science on the messy front lines. It's basically saying his example is real, but his specific role was different, and maybe that difference is key to why his path looks different from the statistical trend among bench scientists or theorists.
Okay, so let's pull these threads together. We've got the nature of the field, clean math versus messy reality, and we've got the type of role bench theory versus administration. The article is saying the specific way a scientist engages with reality is crucial.
That's the author's synthesis, exactly. They're arguing that the whole science-faith debate often gets flattened into just faith versus evidence.
When it's much more nuanced.
Far more nuanced, according to the source. It depends heavily on the kind of evidence you're dealing with and how you interact with it daily.
So the key factors shaping belief, according to this article, are, remind us.
1. The basic type of scientific thinking your field demands every day. 2. how much your work forces you to grapple with complexity, randomness, uncertainty, imperfection. And 3, the actual role you have, hands-on researcher, abstract thinker, or leader interpreter.
So the big takeaway from the source: the mathematician finds an orderly realm, making divine design may be more intuitive. The biologist or physicist faces a more chaotic, unpredictable world, leaving less room for that kind of intuition in their professional view.
That's the essence of it. The physical world, seen from the perspective of biology and physics research, just doesn't look as neatly ordered or purposefully designed as the abstract world of mathematics can appear.
And that's why the simple narrative, look, smart scientists believe, so science and religion get along, is seen by this source as
an oversimplification, because it just papers over these really important differences in scientific mindsets, roles, and daily realities. It matters which scientist and why based on their specific work.
Right. Which brings us back to you, the listener. Understanding these points, as Dr. Pyers lays them out in this source material, hopefully gives you a sharper way to think about the science-faith discussion. It helps show why it's maybe more complex than the easy arguments often make it seem. It's not just one thing versus another. It's deeply tied to how we explore different facets of reality.
It really pushes the conversation beyond those broad generalizations, doesn't it? It makes you consider the specific lens each field provides.
It definitely makes you think about how much the nature of your work can shape your basic outlook.
It's a powerful idea from the source, for sure.
So maybe here's a final thought to take away from this deep dive. Building on that, the article focuses on scientists how dealing with order or chaos or uncertainty in their work influences their big picture views. What about your own life? Think about your job or just your daily routine. Are you dealing mostly with structured systems or navigating messy human dynamics, managing complex projects with unforeseen problems, analyzing incomplete data?
Yeah, that's a great extension.
The way you have to engage with order, chaos, complexity, and uncertainty every day, could that also be subtly shaping your own fundamental perspectives? Your own sense of how the world works or ought to work? It suggests this link between mindset and worldview might apply far beyond just science.